Section 5.3, example 5, finding the x-intercept of a polynomial function using a graph. So at this moment, we did go over how to solve for functions like this, how to find zeros of functions, but let's kind of answer it the way that the book wants us to answer it right now. Let's find the actual graph of this function. You can use whatever means you want to graph the polynomial function. Here I'm going to use Desmos, so that way we could see what the function looks like. So before even starting this problem, I did get it typed into Desmos ahead of time. So our h of x, it's this function right here. H of x is equal to 3x or x cubed plus 4x squared plus x minus 2. And let's just zoom in to see where our function or what our function's doing. Here we have these important values, which are going to be our x-intercepts and our y-intercepts. There we go. So y is equal to, when x is 0, y is -6. So that one was really easy to solve for. The other ones that we have here are going to be our x-intercept. So we have an x-intercept at x equals -3, at x equals -2, and also at x equals 1. So looking at those values, we could factor this to get those values, but we could also just look at the graph the way that the book wants us to do it. So here we have our x-intercepts at our x-intercepts when x is -3, y is 0. When x is -2, y is 0. And also when x is 1, y is 0. The one that we could actually figure out right away is our y-intercept when x is equal to 0. All of these go to 0, and we're just left with that -6. And there we go. Those are all of our intercepts based on the graph. If you have any questions, please feel free to ask. Otherwise, bye.